Welcome students to another session of chemistry. Today we will be studying about acid, bases and salts. The word acid is derived from a Latin word acidus. It means sour. So acids are sour in taste. They always turn blue litmus paper to red. Bases, they are soapy in touch and they are always bitter in taste. Bitter means the taste of Karela, that is very common that you know. And they always turn the red litmus paper blue. And salts are salty in taste and they are neutral in nature. These all are the things that we have been studying from the primary section. So in this chapter, we will be learning a lot more than this. Let us study what is an alkali. So bases that dissolve in water, the bases that are soluble, they are called as alkali. All bases do not dissolve in water. Only those bases that are soluble in water are called as alkali. So here there is a subset that you can see that alkalis examples are sodium hydroxide and potassium hydroxide. Bases examples are copper oxide, zinc oxide, sodium hydroxide, potassium hydroxide. So all are bases. Okay. So, but only alkalis are those type of bases that dissolve in water. Now, as a layman, as you don't know much about the base, you can just remember that if a base is put in an aqueous solution, ionization takes place. Ionization means here a positive ion and a negative ion is formed. If an OH negative ion is formed or an OH is attached, we always say that they are bases. That is a common way for you to remember it. Remember that this answer is not 100% correct. There is much more to it. Here, copper oxide is there. Still, it is a base. But CuOH the whole twice, it can form an hydroxide group. There is an example of ammonia, NH3. It does not have an OH group. Still, it is a base. So we will be learning all about those topics in this chapter. But remember that OH negative is there, it is a base. It is a very easy way to remember it. And at your level in 10th standard, we have almost all the bases which OH. So you can easily identify OH group, yes, it is a base. Exception that you are going to learn more is that of ammonia, NH3. It is also a base. So here you can see that the red litmus paper is being turned into blue and it is a base. Potassium hydroxide is a base because when it is put in aqueous solution, ionization will take place. It will give K positive and OH negative. And what is an alkali? Those bases that are soluble is called as alkali. Examples of sodium hydroxide and potassium hydroxide. Let us learn about the various types of indicators that will tell us whether the substance is an acid, base, or a neutral. It is very important for us to understand whether the substance is acid, base, or neutral because they are being applied in our everyday life. So, what is an indicator? Indicator is a chemical that changes the color in acidic, alkaline, and neutral solution. Some of the common indicators are red litmus paper, a blue litmus paper, phenolphthalein, methyl orange. We'll be learning about it in the next slide. Now let us study what is litmus. Remember, here I am talking about only litmus and not the litmus paper. So litmus is a natural color. It is a natural dye and it is obtained from lichens. You can see over lichens, it is a thallophyte group. And when it is dried, it will turn into blue. And that is how we get litmus. So when a filter paper is dipped in the solution of litmus, it will turn blue. And that is how we get blue litmus paper. So commonly we are going to get only blue litmus paper. So how to get a red litmus paper? Dip the blue litmus paper in an acid. What will happen? We'll get a red litmus paper. And that is how we have got the blue litmus paper and a red litmus paper. So remember, litmus is a natural indicator that will help us to indicate whether the substances are acidic, basic, or neutral. If no changes in red litmus paper and blue litmus takes place, then the substances are neutral in nature. So here you can see the litmus paper test. You can see both the solutions are colorless. We do not know which one is an acid and which one is a base. Both look the same. So if you dip a blue litmus paper and if it turns red, then it is an acid. And if you put a red litmus paper and if it turns blue, then it is a alkali. This type of a question is always asked, that you have been given only one litmus paper, blue, and you have been given 3 solutions. One is acidic, one is base, alkali, and one is a neutral solution. And you have to identify by just a blue litmus paper that which one is acidic solution, which is an alkali solution, and which one is a neutral solution. So you have to dip this blue in all the 3. And if you see that if in one solution that blue litmus paper turns red, then what happens? You have identified that that is an acid. Now take that red litmus paper and put it in the remaining 2 solutions. In one of the solution, naturally that red litmus paper will turn again into blue. So that is the alkali. And third one, in which dip that again the solution. We have already tried that one in which no changes have taken place. So easily you know that it is a neutral solution. So this question is also asked in paper, that there is only one litmus paper blue is given to you and you have to identify which type of solutions are there. 3 solutions are given. The other indicator is an olfactory indicator. And in olfactory indicators, they are the indicators that can be known with the help of a smell. The examples are onion, vanilla, clove. Onion sabko pata hai. Vanilla, I'll be explaining you what is vanilla. I'll have a next slide in which an explanation of vanilla is there. You might have heard about vanilla ice cream. So flavor is added in, of vanilla flavor is added in the ice cream. Clove, aap sabko pata long hai. These all are plant extract and they all are acidic in nature. So naturally these indicators change the smell in a basic solution. एसिड में कभी स्मेल चेंज होने वाला नहीं है. अगर बेस होगा तो स्मेल चला जाएगा. ठीक है. So you have to remember that these indicators, when put in a base, the onion smell will go away, vanilla smell will go away, and the clove smell will go away, indicating that this is a base. And if no changes takes place, indicating that the substances are acidic in nature, because the extracts are acidic in nature. So this is how to prepare a paste of onion. You all know, you have to grate the onion, take out the juice, and in 2 test tubes, there is one acid and one base. You don't know which one is an acid and base. Put little bit of this solution of onion in both the test tubes, and in the test tube in which there is no smell, that means that substance is a base. Even with the vanilla, you can say that you can put vanilla in both the acidic or basic solution test tubes, and in which the smell of vanilla goes away, it is a base. And same thing with the clove, the smell of clove goes away, it is a base. Remember, so you can see how this vanilla comes. It is an extract from a plant seed. The plant seed looks like this and the flower of the vanilla is like this, and that is an extraction that is taken from the vanilla plant. So let us study more about the natural indicators. We have already studied about one natural indicator, and that natural indicator is a litmus. Now there are other natural indicators also. Let us take a red cabbage juice. I think in the red cabbage juice you might have seen in many malls in India, particularly if you go, it is not commonly available in the market. but certain malls and big, now many of them in big cities, they've started keeping this cabbage, red color cabbage. And when you make the juice of red cabbage, it is called red cabbage, but when it looks purplish, so the juice will be like purple. Now take one acid, two solution test tubes or two beakers here, in which one acid is there and one basic there, and in both put little bit of this purple colored juice of red cabbage. And if the color changes to green, it is a base. If the color changes into red, it is an acid. Similar thing is observed by a plant that is called as hydrangea. Hydrangea, if it grows in a basic soil, the flowers are pink in color. And if the soil is little bit acidic, then it will turn into blue. Normally our plants, they grow in a range of slightly acidic or slightly basic soils, not more. It should be near to 7, little bit less than 7, a little bit more than 7. Very less than 7, the roots will be harmed. Very more than 8, the roots will be harmed. So it should be nearly to the range of 6 to 8. So you all know now what is an acidic soil. If it is less than 7, it is called an acidic soil. And if the soil pH level, we'll be studying about pH. Here I'm talking about pH. pH means power of hydrogen. We'll be talking about the power of hydrogen in the topic. So if the soil is acidic in nature, then naturally the flowers of hydrangea will be blue in color. And you can do this experiment at home also. You've got a flower that is blue in color of hydrangea at home, then you can take this basic solution, dilute basic solution, and put that flower with that peduncle inside the solution. It will take that this basic part of it, and slowly you will observe the change in color of the flower. The blue flower will be slowly changing into the pink color. The other famous natural indicator is haldi. It is turmeric. आप खाना खाते होंगे, whenever you can see that the color of your dress becomes yellow, and as you wash with the soap, what happens? It becomes red in color. So soaps are a little bit basic in nature. So you can try out by taking a paper, and on a drawing board paper you can put turmeric on it, and when it becomes yellow, you can make it wet and then put it, and then you take a brush, and with that brush should be dipped in a basic solution, and then you can write anything. It will show you this color. These experiments you can do when in the school certain projects are going on. Now, let us come to the indicators that are synthetic in nature, and here we are going to learn two types of synthetic indicators. One is phenolphthalein and one is methyl orange. Phenolphthalein in acid, there is no change in color. How does phenolphthalein look like? Phenolphthalein is colorless only, absolute colorless. So when it put in acid, the acid is going to remain colorless. So when it is put in base, the base will become pink. So if I give you phenolphthalein and give you one acid and base, and you don't know which one is an acid and base, put 2 to 3 drops of phenolphthalein in both the solutions. The beaker which shows the pink color indicates that it is a basic solution. And same thing about methyl orange. It looks like this. And if 2 solutions are given, put 2 to 3 drops in both an acid and an alkali or a base. And if you see that the color has become red, it is acidic in nature, same. And if it becomes yellow, it is alkali, that is basic in nature. So this is the overview of all the things that we have studied over here. We have studied about red litmus paper, blue litmus paper, phenolphthalein, turmeric, onion, then cabbage. Universal indicator, I'll come to you. I'll be teaching you in the next slide. Now, there are indicators that which have studied, which will just tell us whether the substance are acidic, basic, or neutral. Now we want to know the strength, whether it is a strong acid, whether it is a weak acid, whether it is a weak base, or whether it is a strong base, or whether it is neutral or slightly acidic neutral or slightly basic neutral. These are all things we should be knowing because they help us in our everyday life. So we have got a pH paper. So this is a pH paper, and on this paper, cover paper, is various colors are given. And the range is given. The scale is 1 to 14. And 1 to 14, all the colors are there. You have to remember 3 colors in 10th standard. The first is 1 strong acid is red in color, 2 number is orange in color. Our digestive system, the range of pH in our stomach is 1 to 2. It is a strong acid that is in our stomach that helps the protein to digest. And if it is a strong base, it is 14 number. It is blue in color. Neutral, you'll have to remember, it is green in color. So remember this color: red orange, strong acid; blue, dark blue; violet, it is strong base; and green is neutral color. So first of all, a universal indicator solution is made. And this universal indicator solution is made by taking all the indicators: phenolphthalein, methylene orange, iodine, so methylene blue. All these solutions are put in the universal indicator solution, and that is how an indicator is made. Now, above this also you can see the range is given, just like the same color range is given over here, from 1 to 14 different colors. So whoever pH you want to know, what is the strength of that substance, then you can put those substances few drops of this indicators and note the change in color and match with this. You will easily come to know the strength of the substances. Similarly, if you dip of paper into the universal indicator and then dry it, you are going to get a pH paper. So this will give you a range of it. But exactly if I want to know 2.3, 1.5, 13.4, what is the pH exact? Then that is given with the help of a pH meter. You can see it will give, it is showing here 7.05. Okay, range is 1 to 14. It is not 70. It is 7.1 to 14. It should remain. And you can see it is attached with an electrode. And this electrode is dipped in a solution. And here, depending how ionization has taken place, it will give the reading to this meter. This will give us the exact value of the pH meter. Now, let us come to the part that is reactions that we are going to study over here. Till now, we have studied about various indicators, and in indicators, you should be knowing the natural indicators, the olfactory indicators, and the synthetic indicators. 3 parts we have studied. Now, let us go to the reactions of this acid and base with metals. Yes, acids and base react with metal to give salt and hydrogen gas. So here an experiment is done. We have taken a test tube. We put magnesium pieces over here and added hydrochloric acid. And while we have added the hydrochloric acid in a bent tube, which is put inside the water, bubbles will come. And bring a burning matchstick to it. It will burn with a pop sound. If it burns with a pop sound, that is a test for hydrogen. It indicates that the gas that has been evolved is a hydrogen gas. When it is coming from under the water, it indicates that it is not dissolving in water. And it is rising up, indicates that it is lighter than air. Okay, this is how magnesium looks like. It is grayish color metal. So this is the test for hydrogen. A question can be asked. Tell us the test for hydrogen. You'll have to tell that if you bring a burning matchstick to the gas, and if it burns with a pop sound, then the gas is hydrogen gas. Now, a question is over here. Do all the metals react with acid? What happens over here? This magnesium will displace H. Mg is going to displace the H, and it will take its place, and it is forming MgCl2. The H hydrogen will give rise to hydrogen gas. So, which metals can displace H? Only those metals who are more reactive than hydrogen can displace. Not all the metals can displace H. So, just take care that only those metals that can displace an H will react with an acid. Remember over here, as I told you initially, that in a base, you'll have to remember with the OH group. Just remember it. It is a hint of remembering it. Okay. And here in acid, there is always H. So whenever there is an H, we always have to consider an acid. Exceptions are there. Don't consider ammonia. Ammonia is a base. It has got an H, but it is a base. So exceptions, do remember the exceptions again along with it. So next, let us go to the next slide. So here you can see, here zinc is going to displace H, sodium is going to displace H, magnesium is going to displace H. And that is how hydrogen gas, when it displaces, hydrogen gas is released, and along with that, a salt is formed. Okay, this indicates that zinc is more reactive than hydrogen, sodium is more reactive than hydrogen, magnesium is more reactive than hydrogen. This is how zinc looks, grayish color metal. This is how sodium looks. It is preserved in kerosene. It is very reactive metal. It cannot be kept in open air also, and it cannot be kept in water also. So we have to keep sodium in kerosene. And now with kerosene does not show any reactivity. And you can see magnesium. Magnesium metal always burns with bright light. That you have already studied in the first chapter, giving rise to magnesium oxide. And I think you might have seen Tara Mandal, that you all these things when you are burning during Diwali season. And if it gives a bright light in that, they have put metals of magnesium, and that is how I hope you all might have seen magnesium metal in your life. Let us go with reaction of base with metal. Again, not all the metals react with base. There are few base like the zinc or aluminium. At your level, you have to learn only two, the zinc and aluminium. They will produce hydrogen gas with the production of a complex metal. So zinc will react with OH group. Okay, so it is going to displace H over here and give rise to hydrogen gas, and it is giving a complex salt over here. Okay, it is called as sodium zincate. Now, zinc and aluminium are considered as amphoteric metals. So again, a question over here, which metals are amphoteric in nature? So the examples are zinc and aluminium. So remember, not all the metals react with base. Amphoteric metals react with base, and the examples of amphoteric metals are zinc and aluminium. I will be explaining you what is the meaning of amphoteric. So what is amphoterism? Amphoterism means the ability to react as an acid or a base, and this property is called as amphoterism. You can see an amphoteric substance can act as an acid also, and you can see that the amphoteric substance can behave as a base also. So in exam, many times the question can be changed. Give me names of amphoteric metal. Remember only two over here, aluminium and zinc. Then amphoteric oxide. Then put oxide along with the aluminium group. Aluminium oxide, zinc oxide. You can say aluminium oxide, zinc oxide. Then amphoteric hydroxide. Go to aluminium hydroxide and zinc hydroxide. Remember only aluminium and zinc, and put oxide or hydroxide group along with it. So what are amphoteric compounds? Amphoteric compounds are those compounds that can react both acids as an acid and as a base also. Another famous example of amphoterism is that of water. Water is also amphoteric in nature. We will be learning about it in next few slides. Now another reaction is that of acid with metal carbonates and metal hydrogen carbonates. So when acids react with carbonates, they will give rise to salt, water and carbon dioxide. And if it reacts with hydrogen carbonate, it will give rise to salt, water and carbon dioxide. For that, there is an experiment also. You have to take sodium bicarbonate and put acetic acid. What is acetic acid? Dilution of acetic acid is vinegar that is commonly used while eating a Chinese dish. So when the reaction takes place, a gas that is evolved is a carbon dioxide gas. And through a bent tube, you can allow that carbon dioxide gas to enter in the solution. And here the solution is that of calcium hydroxide. So now the reaction of acid with metal carbonates and metal hydrogen carbonates. Now hydrochloric acid with metal carbonate, copper carbonate. So it is a metal carbonate. So hydrochloric acid is a colorless liquid, aqueous in nature. Copper carbonate is solid. It looks like this. It is green in color. And when the reaction takes place, copper chloride is formed. It is bluish in color. You can see the solution that was colorless. And when the green color is put on it, in it, the solution becomes bluish in color. So the observation you'll have to write, the green colored solid copper carbonate will disappear because the solution was green in color. And now we got the solution of blue colored. Along with large amount of heat is released and bubbles of carbon dioxide is formed. Now another example of acid with sodium hydrogen carbonate. During this process, salt is produced along with water and carbon dioxide. The gas that is produced is carbon dioxide. So observation shows that solid white sodium hydrogen carbonate. So sodium hydrogen carbonate is white in color. It will disappear and the solution becomes colorless. नमक को पानी में डालो तो solution कैसा हो जाता है? Colorless हो जाता है. So the solution becomes colorless. Bubbles are formed and those bubbles are carbon dioxide. So we need to test for carbon dioxide like we did for the hydrogen gas. So the hydrogen gas, we know when you bring a burning matchstick, if it burns, the gas burns with a pop sound, it is a hydrogen gas. Similarly, for carbon dioxide, there is a test. In this, the bubble gas will turn into colorless lime water. The solution will change from colorless to milky if the gas is carbon dioxide. Colorless solution is there, and if you pass in this lime water carbon dioxide, it will turn milky, indicating that the gas that was passed was carbon dioxide. So what is the test for carbon dioxide? It will turn lime water milky. So let us understand this with the help of a limestone cycle. It is not given in your textbook in the form of limestone cycle, but if you understand this in this way, it will become very easy for you to learn. Let us understand what is limestone. The chemical formula of limestone is calcium carbonate. When it is heated, what is formed? Calcium oxide is formed along with the release of carbon dioxide gas. This calcium oxide is called as lime. आपके घर में आपने देखा होगा चूना बाहर मिलता है. Even the people in the pan parlor, they get tuna. That tuna is nothing but calcium oxide. Okay, when water is added, it will release large amount of heat. Matlab, you imagine those people, those who are eating that and putting in the mouth. The mouth has got moisture, so large amount of heat is released, and the slaked lime, that is calcium hydroxide, is formed. This is also, that was just an example for the pan parlor. It is also used for whitewashing a house, and it is also used to build building materials also. So when it is soaked in water, CaO, it will give slaked lime. So the formula of slaked lime is calcium hydroxide. So when you put this calcium hydroxide on the wall, what will happen? When it will dry, wall, तो आप देख सकते हैं जहाँ पर जिस घर में white wash होता है, not the distant person the paint, only white wash. I'm talking about calcium oxide only. So जिस घर में होता है वो घर हमेशा ठंडा लगता है. So the reason that it dries up, then it will release water. So water is released, cooling effect is done. Second thing is, while that a reaction takes place, because it takes carbon dioxide from the atmosphere and it will react with it. So CaOH, the whole twice, will react with carbon dioxide of the atmosphere and it will form calcium carbonate. The dried part on the wall is calcium carbonate with the release of water. Water has been released out. Okay, so you can take, so these are reacting with carbon dioxide and will give rise to calcium carbonate. This cycle will continue. And we can understand this in a better way with the help of this. You can say these are quarries, and from this quarries limestone is taken. This limestone is also called as chalk, or you can say calcium carbonate. It is taken to kill the big furnaces where what happens, it is heated and we get calcium oxide. You can see the cycle also. The CaCO3 is when it is heated, CO is formed, it will release CO2. And when this CaO, what is added? Water is added. You can see large amount of heat is coming out from this. And this forms in calcium hydroxide. So when this is put in a mortar, okay, and that is sands and stones and grits and all this. What happens? And it is applied to the walls to make the houses. What happens? It will absorb CO2 from the atmosphere. You can see CO2 from the atmosphere absorbed. It will release H2O. It will become hard, and again calcium carbonate is formed. So this whole is a calcium carbonate cycle, and you should be knowing this. So here you can see calcium carbonate. When it is heated, thermal decomposition means heated, it will give rise to calcium oxide, that is quicklime plus carbon dioxide. When this calcium oxide, water is added, when to the quicklime, it will form a slaked lime, that is CaOH the whole twice. When this slaked lime will absorb what carbon dioxide, calcium carbonate is formed. Okay, so this is how you should know the limestone cycle. Now let us understand the reactions that is called as a neutralization reaction. And in this neutralization, the acids and base reacts to give rise to salt and water. So in examination point of view, if you say, they will always ask you, what is a neutralization reaction? So neutralization reaction is a reaction in which acid and base they react to give salt and water. You can see over here, this is an acid, that is HCl. This is a base, NaOH. They both are aqueous. They put in water. Then only ionization will take place. And then you can see over here, Na is going to displace this H. It will take its place. Sodium is a reactive metal. It will displace H. And NaCl is formed. What is remaining? H will come and join with its HOH. And that is why CHOH. And therefore water is formed. It is an exothermic reaction during which large amount of heat is given out. So now second, the reaction of metal oxides with acid. Let us take the example of copper oxide. सबने copper oxide देखा होगा. You all have got the vessels of copper base at your house. You can see when it is heated, it forms black coating now below. That black coating is because it has been heated and exposed to the oxygen. Along with the heat, it reacts and forms a black color, and that is copper oxide. Okay. Now this copper oxide reacts with the acid, and it gives salt plus water. See the colors. Copper oxide is black in color, H2SO4 is colorless. So when this black color is added to H2SO4, it forms a blue color copper sulfate aqueous solution. So remember this. Let us take the example of a non-metal oxide. Metal oxide mein, I'll go back, metal oxide. Copper is a metal. So metal oxide. Let us go to the non-metal oxide. Non-metal, put O capital over here. So CO2, carbon dioxide. Carbon is a non-metal, and with oxygen, that it is a non-metal oxide. So when a non-metal oxide reacts with the base, calcium hydroxide, what happens? It will give rise to, we have studied this. Okay, it will in a limestone cycle. It will give calcium carbonate along with release of water. So this is a test for carbon dioxide. It will turn the lime water milky. Okay. So let us go with this. Now, metal oxides are basic in nature and non-metal oxides are acidic in nature. So this is a question that is asked, and you'll have to remember metal oxides. Why metal oxides are basic in nature and why not metal oxides are acidic in nature? So let us take the examples of carbon dioxide, sulfur dioxide, calcium oxide, carbon monoxide, zinc oxide, barium oxide, nitrogen dioxide. Now, if you over here, you can easily identify which is a metal oxide and which is a non-metal oxide. CO2, carbon, आगे देखना है. Carbon is a non-metal oxide. Sulfur, non-metal. So it is a non-metal oxide. Okay, so understand this, which are metal oxides and which are non-metal oxide. We have divided over here. Metal oxides are calcium oxide, zinc oxide, and barium oxide. And non-metal oxide are carbon dioxide, sulfur dioxide, and nitrogen dioxide. When we add these oxides in water, what has happened? Yes, OH group. Calcium hydroxide is formed, zinc hydroxide is formed, barium hydroxide is formed. OH group is formed. OH indicates that it is a base. Remember that. And over here, H is formed. H2CO3. आपकी Pepsi में क्या है? It is a colored sweet water in which colored sweet carbonic water, I can say, because carbon dioxide is added to it in pressure, it becomes cold, and carbon dioxide, it is carbonic acid, sulfuric acid, and nitric acid. This can be known when with the help of a pH meter, and the pH is always How much? If it is a base, pH is always more than 7. And if it is an acid, the pH is always less than 7. Okay, so remember the question. Metal oxides are always basic in nature and non-metal oxides are always acidic in nature. Now, another question that is always asked, that there are certain types of solutions that are acid and base. And if we put that in a solution and 2 electrodes are placed, like over here, a water solution is taken over here, 2 electrodes are placed, these 2 electrodes are joined with a battery, and we have kept a bulb, and the circuit is complete. Now, let us take a dilute distilled water. What will happen? Nothing will happen. The bulb is not going to glow. There's no ions present. IONS, ions, no charges that are present that are going to conduct the charge, that are going to join these two conducting wire. So naturally the bulb is not going to, the circuit will remain incomplete. Let us put a little bit acid in it. What will happen? It will give ions, H positive, base डाल दो, OH negative बनेगा. The NaCl ले लो, N positive and Cl negative, salt लिया, नमक डाला, Na positive, Cl negative, yes, ions are formed, bulb will glow. Second क्या था? HCl ले लो, acid, H positive, Cl negative, in water they will form ions. Okay, so in water, acids are going to form ions, base are going to form ions, salts are going to form ions. Okay, so if ions are formed, acids and base, if they form ions, what will happen? They can carry the charge and the circuit will be completed, and that is how the bulb will glow. But what will happen with glucose and alcohol? Glucose C6H12O6. If I take an example of alcohol, then methanol le lo, CH3OH. When I put this glucose or alcohol in water, no ionization is formed. No ions of H positive or H negative or anything is going to be formed. That indicates that because no ionization is formed, the bulb is not glow. Okay, so the final statement comes over here. The electric current is carried through the solution by the ions. If the bulb glows, then that means the current is flowing, and that means ions are formed. So in an example, when such a question is asked, always draw this figure. Please try to draw a figure in such type of a question. So acid is a substance that will produce H positive. Aqueous means in water, when dissolved in water. And alkali is a substance that will produce OH negative, that when it is in water. So your question is, why do hydrochloric acid, nitric acid shows acidic character in aqueous solution, while solutions of compound like alcohol and glucose do not show acidic character? The answer is, they do not ionize. Alcohol and glucose do not ionize. H positive, Cl negative is formed. Ionization is taken. H positive, NO3 negative is formed. That is, ionization takes place. That is, only if ionization is formed, acidic character is shown. If no ionization takes place, characters like acidic or basic characters cannot be shown. Second question. Why does an aqueous solution of an acid conduct electricity? Same answer. Ionization has taken place. That is why formation of ions are there, and that is why they help in conduction of electricity. Why does dry hydrochloric acid not change the color of dry litmus paper? Okay, to understand this, I have to teach you an experiment. Let us go to this experiment. So, take a beaker, a test tube, NaCl डाला, नमक, जो common salt बोलते हैं हम लोग घर पे, and add H2SO4 to it. Close it with a cork with a delivery tube. In a delivery tube, in front of it, you have to put a guard tube. This guard tube will have calcium chloride. Now a gas is evolved over here. Which gas is evolved over here? You can see during this reaction, NaCl and H2SO4, HCl gas, hydrochloric acid is formed. Okay, when it comes out of this guard, the calcium chloride, what happens? This calcium chloride is anhydrous in nature. Understand, it is anhydrous in nature, indicates that it will absorb moisture. And the gas that comes out is dry hydrochloric acid. It does not contain any water. Now, if you bring acids, they always blue litmus paper red. So if I bring a blue litmus paper over here, what will happen? it will show no change in color. That is why our question was, what does the dry HCl gas not change the dry litmus paper? No, it is not going to change the blue litmus paper at all. But if in this condition, if I bring a moist blue litmus paper, I'll be bringing blue litmus paper only. I know that it is a HCl gas. So moisture is there. So what happened? It has become wet, it aqueous, and it will turn the blue litmus paper red. Indicates that only if ionization takes place, we can say that it can show acidic character, it will show basic character. Okay, so an acid is a hydrogen containing compound, and it will always give free H positive ion in water, not dried one. ड्राई वाइन में H पॉजिटिव नहीं बना था, ठीक है. और सो इधर बहुत सारे क्वेश्चंस आपको आने चाहिए. विच वन इज द क्वेश्चन? Why is calcium hydroxide, why is calcium chloride kept in the guard tube? Calcium chloride is anhydrous in nature and it absorbs water. Therefore, dry hydrochloric gas, whatever gas that comes out will be dry gas. Okay, so your second part. What if a blue litmus paper is exposed to a dry hydrochloric acid? No, it will not change the litmus paper. But if a moist blue litmus paper is brought, it will change the color. Okay. So this was proposed by a scientist named Arrhenius. So he said that acids are substances that dissociates in water to form H positive ion. Acids are going to give aqueous in water, will give H positive ion, and bases they will produce OH negative. After Arrhenius, many more theories had come, and they have modified the Arrhenius theory with many shortcomings that he had. Okay, because one of his theory was all bases have OH negative. No, ammonia is an exception. So all those things were further modified by different scientists. But basic knowledge, you should be knowing that in a base, OH negative is formed, and in an acid, H positive one in aqueous solution. Now, behavior of base in aqueous medium. You can see. NaOH को पानी में डाला क्या होगा? N positive and OH negative बना. Okay, so ionization, in short, ionization has taken place. So let us understand now hydronium ion, H3O positive ion. So to H positive ion, here we have learned that acids, they give H positive ion. H positive को हम protonium भी बोलते हैं. Hydrogen is a element, an atom that contains one proton and one electron and do not have any neutron, hydrogen. So if H positive is formed, positive means it is given away one electron. One electron means it already had one electron and it has given away one electron. So what is remaining in hydrogen ion now? Only a proton is remaining, and therefore it is also called as protonium. But this hydrogen is highly reactive, and it will not remain in H positive state. For a microseconds it remain in H positive state. So what happens with this H positive ion? It will react with another molecule of H2O and it will form H3O positive, and this H3O positive is called as hydronium ion. So hydronium ion is often abbreviated as H positive. It means one is the same, but you should know that H positive ions do not exist in water because it is highly reactive. It will automatically react with any one of the water molecule and it will form a H3O positive ion. Now, amphoteric nature of water. As I told you previously also, which metals are amphoteric in nature? Aluminium and zinc. Which oxides, metal oxides are amphoteric in nature? Aluminium oxide and zinc oxide. Which metal hydroxides are amphoteric in nature? Again, you'll have to say aluminium hydroxide and zinc hydroxide. In the same way, as I told you there, that water is also amphoteric in nature. So what happens with water? Water can behave as an acid also, and it can behave as a base also. Here you can see that in this HCl, hydrochloric acid, This reacting water in aqueous solution will give rise to H3O positive and Cl negative. This H will come and join over here, it H positive, and it will form H3O positive, Cl negative is remaining. Okay, and this H3O positive also called as oxonium ion, but you can better say it as hydronium ion. Again with a base, ammonia is a base, NH3 is a base, it will give us to OH negative and it will give us NH4 positive. It does not have OH group over here, but it is a base because it is giving OH negative. Okay, now let us study about the properties of acids and bases that we have studied till now. Acids, the term blue litmus paper red, they are sour in taste, the pH is from 1 to 6, you have to write. They lose the acidity when they combine base. The reaction is called as neutralization, and they change the color of methyl to orange or yellow to pink, and of methyl, sorry. And acidic, they do not show any change in phenolphthalein, and they reduce the basicity of the bases. Again, more properties of acids. They are corrosive in nature. Corrosive, aapne dekha, you can use it as a toilet cleaner. They corrode the metals. They produce H positive ions in water in aqueous solution. They react with metal to form hydrogen gas. They produce carbon dioxide with metal carbonates or metal hydrogen carbonates. And because ionization takes place in aqueous solution, they help in conduction of electricity. These are the properties of acid that you should be knowing. Same thing about bases. They are soapy to touch, they are bitter in taste. On ionization, they will give OH negative. The range is from 8 to 14. They will turn the red litmus paper blue. They lose the basicity when mixed with water. And acid and base react to form neutralization reaction. And even in aqueous solution, they form ions, and that is why they help in conduction of electricity. Now let us come to another topic over here, and again a very important topic. Strong acids completely ionizing water. Completely मतलब इधर एक H है और एक Cl है, तो इधर एक H positive और एक Cl negative बना. अगर इधर I have written 2 HCl, then 2 H positive and 2 Cl negative will be formed. So completely ions बनते हैं. जितने H इस side होगा उतने ही H positive water में हो जाएगा. Therefore, that is why they are called as strong acid. Strong acid means complete ionization takes place, and that is. So strong acids के नाम you have to remember. They are hydrochloric acid, sulfuric acid, nitric acid, and phosphoric acid. Learn only these 4. Now, what are strong base? Like acids, if the bases they completely ionize in water, they are called as strong base. Here there is one Na, so one Na positive, and OH, one OH, one OH negative. 2 is written, 2 Na and 2 H, and like forward you can, for on you can go. So strong bases, strong alkalis are sodium hydroxide and potassium hydroxide. So what are strong bases? Strong bases are those bases that completely ionize in water. What is the meaning of complete ionization? So I will be teaching you that, but let us study what is the meaning of weak acid and weak base. So weak acid or weak base mein kya bologe? They don't completely ionize. So those acids, they do not completely ionize in water are called as weak acid, and those bases, they do not completely ionize in water are called as weak base. Okay, so strong acids completely ionize in water, strong weak acid do not completely ionize in water. So इसका मतलब ये हुआ कि CH3COOH, it is an acetic acid. Okay, acetic acid is also called as ethanoic acid. It is a weak acid because this will ionize to give CH3O negative and H positive. Here just is an example. If I put here 4 CH3COOH negative, maybe out of it 3 have remained as CH3COOH only. Only one ionization, that is H positive and CH3COO negative. So that is the meaning of weak. A complete ionization is not taken place. Same thing about the base. Okay, when ammonia is put in water, ammonium ion and OH negative form. Let us take 4 ammonia we have put. So out of which only one ammonium ion is formed and one OH negative is formed. Rest we have got 3 molecules of ammonia still there. This indicates that complete ionization has not taken place, and that is why it is a weak base. So remember the name of weak acid. Remember acetic acid is a weak acid, ethanoic acid or acetic acid, one and the same. And ammonia is a weak base, a weak alkali. स्ट्रॉन्ग एसिड्स के नाम याद रहेंगे. इट इज हाइड्रोक्लोरिक एसिड, सल्फ्यूरिक एसिड, नाइट्रिक एसिड, फॉस्फोरिक एसिड. स्ट्रॉन्ग बेस सोडियम हाइड्रोक्साइड, potassium hydroxide, calcium hydroxide, and weak acid, you remember only one, it is acetic acid. Weak base, remember ammonia. Okay, this much is enough for you to remember. Now let us understand some of the naturally occurring acids, and they are substances that we can take. They dilute, they are not so strong in nature. Let us take lemon, it has got citric acid. Tamarind, tartaric acid. Vinegar, acetic acid. Apple has got malic acid. Curd, dahi, lactic acid. Dahi में milk में lactose होता है, it turns into lactic acid. Honey bee or ant, आपको अगर sting करे, it is formic acid, also called as methanoic acid. And tomato, it has got an oxalic acid. Remember this, you'll have to remember this. So strong acids, names, it's hydrochloric acid, sulfuric acid, phosphoric acid. Weak acid is acetic acid. Strong bases, potassium hydroxide, sodium hydroxide, magnesium hydroxide, even calcium hydroxide you can say. Weak bases, ammonium hydroxide. Now, there's another topic to it, dilute and concentration. So don't mix up with strong and weak acid. Strong और weak acid हम लोग हमेशा relate करेंगे ionization के साथ में. So अगर ionization हुआ है, इसका मतलब क्या है कि complete ionization, that is strong acids, and complete ionization नहीं होता weak. वो topic totally different है. Leave that topic aside and now come to another topic, that is dilute and concentration. Dilute कोई चीज को करना था पानी ज्यादा डालो, concentrated रखना था कम. एक glass पानी लो, put one sugar in it, it is a sugar solution only. Okay, now it won't be that sweet. If I put more sugar to it, what will happen? It will become more sweet. If I want to add how much ever more sugar to it, I'll heat up and dissolve it. It will become more sweet in nature. That means you're increasing or decreasing the water to increase and decrease the concentration. अगर पानी जैसे कि लास्ट में आपने चाशनी बनाई, सिर्फ बनाया शुगर का, that means you have added, there is less water, or as in comparison to the solid that is added, then it is concentrated solution. अगर उसमें ज्यादा भर के पानी दो, जैसे नींबू पानी बनाना, 4 चम्मच पानी चीनी डाली and then you put the water, what will happen? It is a dilute solution. So dilute acid में water is more and concentrated solution में water is less. Let us take this dilute and concentrated. Concentration में आप देख सकते हो, there are more solid particle and less water to it. There is more water and less solid in it. Let us take a weak acid and a strong acid. Weak and strong are related with ionization. Either weak में देखो ये अलग हो गए हैं, but relatively one, जैसे I told you only one has separator, so ये दोनों ions बनेंगे, one positive and negative. Rest they stayed as it is. Okay, as a salt it is remained, or as a acid it is remained same. And here you can see strong acid, full ionization. कोई भी एक ऐसा नहीं है जिसमें ionization है. They separate out to form positive and negative ions. So weak acid ionization is incomplete. Strong acid ionization is complete. Dilute acid को water साथ relate करना है. Dilute acid has more water content in it. Concentrated solution is less water in it. So these two are completely different topics, and don't mix up these topics together. Here again the examples of strong and weak acid. आप strong acid बोला तो strong acids में क्या हुआ था? सब H positive A negative, H positive A negative, completely it will be. And weak acid में क्या होगा? सब HA रहा है and few only negative and positive ions समेत. Dilute and concentration में कैसा किया हुआ है? Dilute and concentration में water content is more over here and water content is less over here. So again, certain examples of strong and weak acid. These are molecules of acid and base acids. And if I put it in a strong acid, if it is a strong acid, complete ionization has taken place. Positive and negative ions are formed. And blue are taken as hydrogen ion that are positive. Red is taken as negative ion. And if it is a weak acid, if this substance is a weak acid, what will happen? They are not going to ionize completely. They are not separated. Only one or two have separated out, not separated completely. So weak acid का एक example दे दीजिए, आपको एक ही याद रखना है. It is acetic acid. Now another question. what happens to an acid or a base in water solution? You can see the person has in his hand is an acid and he is putting it in water. What is happening? It is exothermic in nature. Large amount of heat is remaining. So whenever an acid is added to water, large amount of heat is obtained, and this is a highly exothermic reaction. Why we are talking about this? Because you don't have to do reverse of this. You cannot keep water in your hand and acid over here. What will happen if the reverse is done? It is disastrous. Violent splashing of acid will take place and large amount of injuries can take place. So the title always comes, add the acid. Add the acid means this. Add the acid to water. So always remember the title, add the acid. So your caution, always add acid to water. If you are taking water and putting it in acid, it is very much disastrous. ये भी question एक exam में पूछते हैं कई बार कि why we should we add acid to water or water to acid? No, don't never do water to acid. Same thing about the base. Can I add water to the base? Same thing will happen. Acid okay, base ho, same. Okay, and here also if instead of acid, if I take a base to water, then yes, it is going to remain the same. If I take a base and put it in water, it is exothermic and large amount of heat will also occur over here. Okay, now we are going to come to the topic that is called as a pH scale. pH, as I told you, power of hydrogen. P stands for potence, in German meaning power, and H is hydrogen, therefore it is called as power of hydrogen. As I told you, 7 means neutral, it is green in color. If you're moving towards the 1, the strength of acid is becoming more. And if you're moving towards 14, the strength of base is going to more. From 7, if you move on the other directions, if you're going towards the right, that is if you're reaching to the 14, strong acid. 8 kya hoga? Weak base. Okay, strong acid. Weak is 4, 5, 6, the weak acid. So this is how you can know. So 0 to strong acid, 3 to 6 weak acid, 7 is neutral, 8 to 11 is weak alkali, and 12 to 14 is strong alkali. Remember the colors also. So what happens? Why it is called neutral? Because it is called neutral because H positive ions are always equal to OH negative. OH negative ions indicates that they are basic in nature, and H positive ion indicates that they are acidic in nature. Okay, so neutral 7 H positive is always equal to OH negative. As you are moving towards the strong acids, what is happening? The H positive concentrations are going to increase more and more. And that means H positives are more over here and your OH negatives are more. So here are a few of the conditions. pH 2 है हमारे gastric juices के लिए, tomato juice का pH 4 है, urine is acidic, uric acid, it is pH 5, pure water 7, blood is slightly basic in nature 7.4, your soap is basic in nature, it is pH level 10, strong base होता है, and your bleach is 12. It is, I think we have learned about universal indicators and we have already learned about pH papers. Now again an important question over here. The question is importance of pH in everyday life, and you'll have to write down all the points of importance of pH in life. There are many points to it. We'll go one by one. First point, pH sensitivity in plants and animals. We are very pH sensitive. A slight change in the pH level will affect the life of living organisms. Acid rain hoga to kya hoga? Or people will die. There many organisms will die. The plants that are surviving, they will also die. So it affects the human being and all. So our body works with a very fine range of 7 to 2.8, and living organism can survive only in this narrow range. Okay, we cannot survive in an acidic environment or very strong basic environment. So what happens over here? How acid rain comes? All the coals and everything they contains impurity has sulfur and nitrogen, and once they are burned, a combustion takes place. They release sulfur dioxide and nitrogen dioxide. They mix with the rainwater, and down comes the acid rain. And when there is acid rain, the pH level goes as low as 5.6, And when such water flows in the rivers, it will change the pH of the river. The pH will change. The organisms living in water will also die. It will become difficult for the aquatic animals. And if it falls on the green plants, again, they are going to be affected. It affects many living organisms that are still living in the soil. Second, effect of pH. What causes our tooth decay? So let us understand how a tooth looks like. Okay, this is a pulp part. This is a gums on both the sides. There are bones. This is dentin. And the hardest part of our body is the enamel. The white part of your tooth is the hardest part. So how does the infection takes place? When you're eating the food, and if the food remains over here for a longer amount of time, the bacteria start staying over there. They start multiplying. And when the bacteria stay over here, they release a chemical, an acidic chemical. And that food will be digested and they'll absorb that food as a nutrition. But since they've released an acid, what will happen? It will start decaying or making holes in our teeth. And that holes are called as cavity. And that is how our teeth forms cavity. So tooth decay starts when the pH in our mouth goes below 5.5. The enamel is made up of calcium phosphate and it is the hardest substance in the water. It does not dissolve in water, but it is corroded if the pH level goes less than 5.5. Bacteria, they produce acid so that they can break down the food and they can take in the nutrition. So you have to always clean your mouth so that the food particles do not stay in your mouth. Now, we use our toothpaste, and this toothpaste are basic in nature. Okay, therefore they help to prevent the tooth decay. If an acid has been formed by in our tooth, in our mouth, the paste can help to make a reaction that is called as neutralization. Acid plus base will give rise to a neutralization reaction, salt plus water. The ideal condition for the salt to grow is either slightly acidic or slightly basic. 7 से थोड़ी 6 की तरफ जाओ और 7 से ये रेंज है कि आइडल्स है. इस साइड जाओ तो नहीं चलेगा. वो सॉल्ट जो एसिडिक हो गया है, add lime to it. Lime is base and therefore the solution come back to neutral to it. Even if the alkaline soil has become highly alkaline, you have to put little bit acids to it, like carbonic acids, to make it normal to neutral. So this is an ideal condition for a plant to grow, that is between 6 to 8. pH in our digestive system, we have already learned in our chapter life processes that hydrochloric acid is secreted in our stomach and that helps in digestion of protein. Sometimes more acid has been formed in our stomach and it will remove the mucus layer that gives a protection to our stomach, and because of that we get large amount of pain and irritation, and in order to remove such pain and irritation we have to take antacids. Acids को break करने के लिए antacids. So which is an antacid? Antacids are base in nature so that the neutralization reaction takes place in your stomach. So we have to neutralize the acid by taking antacids, and one of the famous antacids that you say it is Digene, that is a common term that you take because they are like mineral water. कौन सा लेना है? तो Bisleri. Bisleri means not mineral water, means it is a brand. So Digene is a brand over here, but the content you have to go for it, and the content is magnesium hydroxide. It is called as milk of magnesia. Okay. Another example is that of honeybee. सबको लगता है honeybee ने हमको काट लिया, क्या करना चाहिए? लगाओ घर बेकिंग सोडा लगाओ, साबुन लगाओ, and rub it with your hand so that the neutralization reaction takes place and does not harm your body. Okay, and if it is a wasp यानी वो मिट्टी का घर बनाते हैं आपके घर में, उसका स्ट्रिंग अल्कलाइन है, बी का स्ट्रिंग एसिडिक है. So remember, honeybee करे तो आपको बेस लगाना है, wasp स्ट्रिंग करे तो आपको एसिड लगाना है. आपके घर में विनेगर होगा, and therefore you can use this as a neutralization reaction. Nature provides neutralization options. If you go for a trekking out in the market, and suddenly आपने एक plant को touch कर लिया. Normal instructions होता है don't try to touch the plant normally, otherwise you will get itching in your body. So there is a plant that is called as a nettle plant. और वो nettle plant में if you touch that nettle plants, what will happen? उसके थोड़े strings होते हैं, that the string that is acidic string in it, methanoic acid string होता है. वो string आपके body में जाएगा तो आपके body में irritation और सब शुरू हो जाएगा, because that is a protective mechanism of your body for itching, because they have released histamine. But the thing is, they have injected methanoic acid in your body, and that is why what should be done? Nature ने अपने आप ही बनाया हुआ है कि जहां पर भी नेटल प्लांट होगा उसके पास में डॉग प्लांट मिलेगा. You'll get a dog plant, and that is basic in nature. This is acidic, this is basic. Just take this plant, rub it on your skin, and what will happen? A neutralization reaction will take place. Okay. Why is pH of a blood important? हमारे blood का pH कितना है? 7.0 to 7.8. And जितने भी enzymes है, proteins है, catalyst है, वो सब इसी range पे काम करते हैं. We are not going for the buffer solutions. Okay. Now the last topic of this is salts. Salts means we have learned acid plus base will give rise to salt plus water, or a metal plus acid will give us a salt plus hydrogen. So what is a salt? So examples of salt are potassium sulfate, sodium sulfate, calcium sulfate, sodium chloride, namak आपके घर में common salt it is called as. pH of the salt is 7. It should be less than 7, slightly less than 7, between 6 and 7. It is called an acidic salt. If slightly more than 7, between 7 to 8, it is called a basic salt. I've already told you that the salts, it can be exactly neutral. Exactly neutral salt is formed only when the reaction takes place between a strong acid and a strong base. Okay, then if it is an acidic salt, that means acid is strong, base is weak. And if it is a basic salt, that means it is a strong base and weak acid. So reaction between a strong base and weak acid will give rise to a basic salt. A reaction between a strong acid and a weak base will give you a acidic salt, and reaction between a strong acid and strong base will always give you a neutral salt. It is green in color, remember this. So we have already studied this about like what are salts. Acid plus metal will give salt plus hydrogen. Then acid plus base will also give salt plus water. So there are many reactions that we learn. Let us study about the common salt. आपके घर में जो नमक मिलता है, नमक कहाँ से मिला? हम लोग ज्यादातर बोलते हैं सी वाटर में से मिला. ठीक है, नमक. The sea water is a mixture of many salts. It is NaCl, KCl, potassium nitrate. So many salts are present over here. But we are getting that salt. We are eating that salt, that is common salt, and that is sodium chloride. That is obtained from the sea. It is also formed senda namak bolte, brown colored salt that is there. It is also called as rock salt. How rock salt is formed? Many years ago, that region must have been in place of sea and oceans. The sea might have gone ahead. For example, you can take the example of Lothal. Lothal tak pehle sea tha, ab sea kahan chala gaya hai? Bhavnagar side chala gaya. So the whole region of sea and deposits of salts will get from such places, and that salt is called as rock salt. It is colored because it contains impurity. Impurity does not mean sand or this thing over. Impurities means certain other small chemical may be over here inside it. A chlorine may be, chloride salt content may be over here, or a certain impurities of certain minerals are present inside it, and that gives the color to it from brown, light brown, such colors. Today, the salts that we are going to study that will be obtained from common salt. So what all can we get from common salt? NaCl में से हम क्या क्या मिलने वाला है? तो हम जो पढ़ने वाले हैं उसमें से मिलेगा sodium hydroxide. Second, we will get washing soda, baking soda, bleaching powder, POP, plaster of Paris. ये सारे नाम आपने सुने होंगे, and we will be studying that over here. So this is an important figure that is given in the textbook. ये नमक है, NaCl लिया हुआ है. ये नमक से हमको क्या क्या मिल रहा है? क्या क्या मिल रहा है? So इस नमक को पानी में डालें तो the solution is called as a brine solution. So what is a brine solution? What salt in water is called as a brine solution. And when electric current is passed through it, we get NaOH, sodium hydroxide, Cl2 and H2. So here it is. Brine solution, on passing electric current through it, we get H2, Cl2 and NaOH. This is called as chlor-alkali process. The question ho jata hai, what is chlor-alkali process? Chlor-alkali process is a process, this is a chlor-alkali process, during which in a brine solution, when electric current is passed, we will get sodium hydroxide, chlorine and hydrogen. And different products can be obtained, and we'll be studying the uses slowly and slowly about all these topics. So first of all, NaOH. तो NaOH मिला कैसे? तो NaOH आपको पता चल गया, ब्राइन सॉल्यूशन, नमक को पानी में डाला, डिकम्पोज हुआ, break down हुआ, and we got NaOH. It is called as chlor-alkali process. This, okay. Now, second was bleaching powder. Bleaching powder कैसे मिला? The chlorine that was produced during the chlor-alkali process, chlorine, उसको react किसके साथ किया है? Calcium hydrox के साथ किया है. तो we've got bleaching powder. The formula is CaOCl2 plus water. Okay, so this is how bleaching powder is obtained. So bleaching powder is produced by the action of chlorine on dry slaked lime. What are the uses of bleaching paper? कहाँ कहाँ आता है? पेपर इंडस्ट्री में काम आएगा, ब्लीच करना है, क्लोथिंग इंडस्ट्री को ब्लीच करने के लिए काम आता है. ऑक्सीडाइजिंग, इट इज अ वेरी स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट एंड दिस यूज्ड एज डिसइंफेक्टेंट. मतलब आप देख सकते हो कि उसको क्लीन करने के लिए भी करते हैं. ड्यूरिंग after the rainy seasons, our municipalities they come to clean and they put powders on certain areas where there is large amount of water gets collected, or in order to remove the germs, they put the powder, that is a bleaching powder. So you can see here it is used as a disinfectant in a water treatment plant. Second is baking soda. सबने बेकिंग सोडा सुना होगा, घर पे पकोड़े बनते हैं घर में, तब बेकिंग सोडा डालते हैं क्रिस्प बनाने के लिए. सो बेकिंग सोडा कैसे बनता है? सो पहले तो इसका फॉर्मूला देख लेते हैं कि कैसे बना है. बेकिंग सोडा इज NaHCO3, सोडियम हाइड्रोजन कार्बोनेट. और कैसे बना? नमक को पानी में डाला, ठीक है, ब्राइन सॉल्यूशन, और उसको हमने कार्बन डाइऑक्साइड और अमोनिया के साथ रिएक्ट करवाया. अमोनियम क्लोराइड प्लस बेकिंग सोडा मिला है. ये हमारा कई बार if we make certain beans and it takes 2 hours 1 hour for it to be cooked, we put little bit of soda in it so that the cooking time reduces. That is also the reason why we put baking soda in food. So what are the uses of sodium hydrogen carbonate? Sodium hydrogen carbonate यानी बेकिंग सोडा का काम क्या है? ठीक है, तो सबसे पहले बेकिंग सोडा का काम है बेकिंग पाउडर बनाना. तब याद रखना, बेकिंग सोडे की वजह से बेकिंग पाउडर मिलता है. बेकिंग पाउडर आप लोग केक बनाने के लिए यूज करते हैं. बेकिंग सोडा पकोड़े में डालते हैं क्रिस्पी करने के लिए या खाने का कुकिंग टाइम डिक्रीज करने के लिए. मगर अगर आपको केक बनाना है तो आप क्या डालोगे? बेकिंग पाउडर डालोगे. तो बेकिंग पाउडर कहाँ से बना? फ्रॉम वेयर विल वी मेक बेकिंग पाउडर? इट इज ऑब्टेन्ड फ्रॉम बेकिंग सोडा. और इस बेकिंग पाउडर में थोड़ा अमाउंट ऑफ टार्टरिक एसिड डाला जाता है. इट इज अ मिक्सचर ऑफ टार्टरिक एसिड एंड बेकिंग सोडा एंड दैट इज हाउ बेकिंग पाउडर इज ऑब्टेन्ड. ओके, आप ये देख सकते हो कि दिस सोडा, इवन इफ यू पुट इन वाटर, इट कैन बी यूज्ड एज एंटासिड्स. ओके, इट गिव्स रिलीफ टू योर स्टमक एंड इट इज आल्सो यूज्ड एज सोडा एसिड एक्सटिंग्विशर. सेकेंड इज वॉशिंग सोडा, कपड़े धोने का साबुन. वॉशिंग सोडा, तो वॉशिंग सोडा का फॉर्मूला क्या है? तो वॉशिंग सोडा का फॉर्मूला है Na2CO3 10H2O. ओके, दिस इज सोडियम कार्बोनेट. सोडियम कार्बोनेट का फॉर्मूला क्या है? Na2CO3. So when Na2CO3 is water is added to it, it will form Na2CO3 10H2O. And this 10H2O is called as water of crystallization. So आपको एग्जाम में कई बार पूछा जाता है कि what is the formula of washing soda? Then you will have to write Na2CO3 10H2O. This is washing soda and this is sodium carbonate. I'll be teaching you this 10H2O means water of crystallization. So uses of washing soda. It is used in glass industry, in the soap industry, paper industry. आपके घर में domestic purpose के लिए cleaning के use करता है. It is useful to remove the hardness of water. आपका जो drinking water, it is from your distilled water, then it is a soft water, but the tap water is mostly hard water. So if you are using soap in it, it will remove all the salts from it. The salts precipitate out. Precipitate means solid बन जाते हैं. और जो पानी रह जाता है उसमें से सारे सॉल्ट सॉलिडिफाई करके आपने निकाल दिया है, फिल्टर इट आउट, यू विल गेट अ सॉफ्ट वाटर. सो इट इज यूजफुल टू रिमूव द हार्डनेस ऑफ वाटर. यू कैन मेक अ हार्ड वाटर सॉफ्ट विद द हेल्प ऑफ अ सोप. ओके, एंड हियर कम्स बेकिंग पाउडर एंड बेकिंग सोडा का डिफरेंस. किसको कहाँ यूज करते हैं आप देखो, इधर केक की तरह यूज किया हुआ है. तो कोई भी चीज ऊपर की ओर फुलाना हो, केक कैसे फूलता है ऊपर, ठीक है. CO2 gas is released, that is for sure, that is why you get holes in it, that bubbles will give you holes. बेकिंग सोडा किसके लिए काम आता है, मफिन्स सॉफ्ट, देन आपका ये पकोड़े बनाने हैं उसमें यूज होता है. सो व्हेन टू यूज द इंग्रेडिएंट्स एंड रेसिपी विल डिटरमाइन व्हिच प्रोडक्ट इज नीडेड. बेकिंग सोडा इज यूज्ड इन कुकीज एंड मफिन्स एंड बेकिंग पाउडर इज यूज्ड इन केक्स एंड बेक्स. वही है, आपको याद रखना है कंसेप्ट. ऊपर की ओर फुलाना है तो आपको बेकिंग पाउडर यूज करना है, और फ्लैट रखना है तो आपको बेकिंग सोडा यूज करना है. व्हाट हैपेंस व्हेन बेकिंग पाउडर इज हीटेड. हुआ ना, आपने बेकिंग पाउडर किस में डाला, केक बनाने के लिए डाला, अब उसको हीट कर रहे हो तो आपका जो टार्टरिक एसिड का H पॉजिटिव है, कि आपको उसका फॉर्मूला लर्न करने की जरूरत नहीं है, एसिड का H है, वो रिएक्ट करेगा इसके साथ में और आपका रिलीज हो जाएगा कार्बन डाइऑक्साइड गैस. सो बेकिंग पाउडर हम के अंदर कौन सा एसिड होता है, टार्टरिक एसिड. वो टार्टरिक एसिड का H will react and what will happen, carbon dioxide is formed along with the formation of sodium salt of an acid. Now as I told you, I will be explaining about water of crystallization. So let us take the example of copper sulfate. Copper sulfate 5H2O. So copper sulfate, it is in a crystal form. It will give, the number of water molecules will be 5. We have learned about in washing soda, the number of water molecules were 10. Here I will go to that side. 10H2O. So washing soda has got how many water molecules? We can also call as water of crystallization. So how many water of crystallization? It is a 10 molecules of water. And how many water molecules are there in copper sulfate? Crystal form 5H2O. So when it is heated, heat karo to water will be removed. It will give rise to CuSO4. Again, if water is added, it will form this. Another example is that of iron sulfate. Iron sulfate 7H2. How many water of crystallization water molecules are over here? 7. So FeSO4 is green crystals in nature. This is a sugar crystal. So what is efflorescence? अगर water molecule remove हो जाता है तो efflorescence हो जाता है, अगर water molecule add होता है तो crystallization हो जाता है. So crystals कैसे form होते हैं? Crystal इसलिए form होते हैं, उनके पास they've got a special shape. Every crystal has its own shape. Okay, and in it water molecules are added to it. For example, copper sulfate, if it has got 5 water molecules, then washing soda has got 10 water molecules, then iron sulfate has got 7 water molecules. And if you want to remove these water molecules, just heat it and they are removed, and that is called as efflorescence. So here the difference between the color of the water molecules. ये color copper sulfate का है when water of crystallization has what? It has got water of crystallization. Water molecules are present. And अगर उसका what ये content निकाल दिया, 5H2O निकाल दिया, तो क्या हो गया? White color. So you can see. This is CuSO4, this is CuSO4 5H2O. CuSO4 5H2O का कलर कैसा हो गया? ब्लू. और CuSO4 का कलर कैसा है? व्हाइट है. Okay, so they are hydrated form. Hydrated means water. Anhydrous, कोई water नहीं. Anhydrous white in color है. अब वो blue crystal है. Again the same white powder and blue crystal. This is a hydrous form and this is a non-hydrous form. 5H2O. Just remember 5H2 and CuSO4. These are the different crystals. Blue vitriol 80 और 10th level. Just remember, अगर blue vitriol का solution copper sulfate का बनाएंगे blue बनेगा. Green vitriol का बनाएंगे FeSO4 आपका green है. बाकी जितने भी वाटर सॉल्यूशन आपके लेवल में आपको केमिकल रिएक्शन तक पढ़ने हैं सब व्हाइट कलर के. तो अगर CuSO4 बनेगा तो याद कर देने का पानी में ब्लू कलर है. अगर FeSO4 बन रहा है पानी में तो आपको याद रखने का ग्रीन कलर वो सॉल्यूशन बना है आपका. ठीक है, बाकी सब कलर्स आपके बनने ही नहीं वाले, व्हाइट ही रहने वाले हैं. सो put it that colorless. You'll have to remember this. Blue vitriol is copper sulfate. It has got 5 molecules of water of crystallization. Then gypsum, CaSO4 2H2O. Then green vitriol, FeSO4 7H2O. White vitriol, ZnSO4 7H2O. Epsom salt, namak khate honge, that is MgSO4 7H2O. So where are water trapped? What is trapped like this in the water of crystallization? Okay, so water molecules are trapped inside the crystal, and therefore this is called as water of crystallization. This is example cobalt chloride. Let us go to the another topic, that is gypsum and plaster of Paris. POP सबने देखा होगा, कईयों के घरों में POP के ऊपर सीलिंग भी होती है. तो POP कहाँ काम आता है? ये मैन मेड है, ये ड्राइड है. आप उसको कोई भी शेप में मोल्ड कर सकते हैं POP, एंड यू कैन पुट इट इन डिफरेंट शेप्स. अगर गीला है सूखने के बाद में. और इसका फॉर्मूला क्या है? कैल्शियम सल्फेट हेमीहाइड्रेट, CaSO4. हेमी मतलब आधा, हाफ H2O. क्लियर है? कहाँ कहाँ काम आता है? यू ऑल नो दैट. सो अगर ये हेमीहाइड्रेट कहाँ काम आता है? ओके, लेट मी सी ओवर हियर. इट इज यूज्ड इन मेकिंग सीलिंग्स, डेंचर्स, डेंटिस्ट्री में डेंचर बनाने के लिए, डिफरेंट ऑफ आइडल्स, एंड आल्सो यूज्ड फॉर प्लास्टरिंग ऑफ फ्रैक्चर बोन. Your gypsum is there. It has got how many water of crystallization molecules? 2. CaSO4 2H2O. And if from your water molecules remain, only half H2O remains, it becomes POP. Okay, so gypsum में से POP बना सकते हैं. क्या करना है? खाली आपको हीट करना है और half H2O हेमी हाइड्रेट, और ये हो गया है. It was remaining. So what is the formula of gypsum? CaSO4 2H2O. What is the formula of plaster of Paris? CaSO4 half H2O. Dihydrate, hemihydrate. Cannot be molded into different shapes. It can be molded into different shapes. When it is wet, it is a natural occurring. It is a man-made. We have heated it, therefore it has become man-made. Okay, the last topic is water of crystallization. Just learn how many water molecules are there in all this crystallization. 2 water molecules are there, 10 water molecules are there, 5 water molecules are there in copper sulfate, washing soda, and gypsum. Thank you so much.